My name is Eric Johnson. I'm a technical program manager. I work in the Seattle office on the compute engine team. And I was going to take a little bit of your time today to tell you a little bit about Google Cloud Platform in general, and then also some of the integration work that I and some colleagues have done to make sure that Chef works well with compute engine. So in the spirit of the conference, hopefully this stuff will delight you. Let's see. All right, so we'll start with a whirlwind tour of the Google Cloud Platform and then a deeper dive on Compute Engine, and then I'll show you the demos that we have. So for Google Cloud Platform, we kind of have this partitioned up into three different buckets, I guess, let's say. So there's on the compute side, we have Google Compute Engine, which I'll talk about in much more detail. And we also have App Engine, which has been around, I think, since 2007, so I would imagine most people have heard of App Engine. You'd use App Engine if you had a web application and you didn't want to worry about scaling, auto-scaling, whether that's scaling the data store, which you can use, or the actual front-end service. Snapchat is a huge customer that uses App Engine, and if you saw our cloud event from a couple weeks ago, there was an interview with Snapchat founder about how he just doesn't have to worry about scaling any of his apps. On the storage side, we have cloud storage, which is blob storage. Cloud SQL, which is managed MySQL database in the cloud, so you don't have to take care of things like replication or scaling that out also. Cloud Data Store, that's the, originally that was the data storage available to you through App Engine, and we've pulled that out as a separate service, and so that's accessible from Compute Engine as well as just natively. Application services, apologize, I'm going to go really fast through this stuff so that I can get to the demo so that we have enough time to cover everything. So I'd encourage you to come back and ask questions about any of this stuff. So I'm kind of skipping through. I kind of talked about the compute stuff, the storage stuff. On the app services, we have BigQuery, which you can dump in terabytes of data and sort that stuff, query it in seconds. So it's a great way to, if you have a lot of data that you want to analyze, you can upload it into BigQuery, or you could upload it first into cloud storage and then pull it across into BigQuery and run ad hoc queries against it. It's an SQL-like syntax. It also supports real-time streaming. So if you have an application, you can actually just feed it right into BigQuery and you can analyze this stuff on the fly. There's a great Google Developers Live video that talks about a company that has built a lot of instrumentation into their application for profiling information. So as they do a release, they can actually query, how that has changed rendering times of pages and things like that. So they can identify regressions just based off of the data they're feeding into BigQuery. Cloud endpoints, if you have an application that you want to expose a REST API to, say for mobile development, this is a great service to take a look at. It'll actually auto-generate the language bindings, I think in Java and a few others. So you can actually develop your application and expose a REST endpoint right to cloud endpoints. And then we also came out with Cloud DNS. We announced that at the cloud event from a few weeks back. So that's kind of, in a nutshell, a lot of the services. And, I didn't even cover anything about like why you would use them. But why would you use Google, right? So Google has been doing this for about 15 years now. And we haven't really been selling it as a public cloud, right? But we've used this to power some of the applications that you're probably very familiar with. We have a network that spans the entire globe. And one of the advantages that we have where we take advantage of the network is we'll try and get users onto our network as quickly as possible. So wherever you're located, we're going to get you onto our backbone so that you've got low latency, high bandwidth access to cloud services that we sell. We're also innovating. So not only do we innovate sort of at the data center level and the networking level, but we also do it obviously in the application level. Years and years ago, we published white papers on GFS and MapReduce and Bigtable, and those have spawned the sort of open source movement around a lot of the big data like Hadoop, Cassandra. A lot of those were built on their open source implementations based on the data that was published in our white papers. But since then, Google has kind of moved on ahead where these applications served us well at the time, but as Gmail and YouTube and those types of applications blossomed and users grew and usage grew, we needed to find other ways to scale beyond what those were capable of. So we've gone off and we've, Dremel is the service that allows you to query large data sets, and that's what powers BigQuery. Colossus is our data storage underlying. Spanner is a global-wide SQL-like database, and obviously Compute Engine. And that uses a lot of the same virtualization technology that we use internally to run all of our applications. So a few that you're probably very familiar with. And this is a great quote. This came out of the Wired magazine from Stephen Levy, and I love this. Google's ability to build, organize, and operate a huge network of servers and fiber optic cables with an efficiency and speed that rocks physics on its heels. So I don't know, it's a very nice quote, but it's actually kind of true, right? Like we have, in order to be able to produce these applications that service hundreds of millions of users, we've had to really kind of like almost bend the laws of physics in some of the things that we do. And the movement that we're making right now with getting into cloud is we're just making sure that all of those infrastructure and software systems and innovations are available to you. All right, so let's do a deep dive of Google Compute Engine. So this is our infrastructure as a service, right? It's virtual machines in the cloud and networking and some storage. And as I was just talking about, right, this has Google DNA built in through it. So speed, security, scalability, all of those things that Google engineers take advantage of to power Gmail and YouTube, we're now offering as a service to you as well. Fast provisioning and consistent performance. And I'll show you a little demo of the fast provisioning. Google Compute Engine last year was when we came out with this, and at the beginning of 2013 it was invite-only access. But then in I/O last year, we went to open signups. So anybody could get in and use it. And then in December, we went generally available, so now anybody can use it. And part of being generally available is we want to make sure that there's an SLA behind it. We've got support for it. So it's something that you can really build your business around and depend on. It's accessible through a web, and I'll show you a developer console that we have that allows you to get in and create instances and take a look at that information. We have a command line utility we call GCUtil, and it's a Python script and a REST API. And so the combination of those things, the REST API is the public interface, obviously, to using the service, and both the developer console, the web access, and the GCUtil command line utility, all of those just use our public API. So there's no sort of magic, behind the scenes access to this stuff. So anything that one of these tools can do is something that you would be able to replicate with your own tooling. And partners, right? So we've got pretty good presence with commercial partnerships, as well as a lot of open source software, including Chef that uses or can use Compute Engine now. So with that, let's do the first demo. So what I've got here is it's a screenshot of, and I'll actually bring it up here. So this is, we call this our quick start demo. Oh boy, looks like I didn't reset that. So let me give that a few seconds. So what this is it's a demo that allows you, obviously you specify the number of instances you want to create, and then it'll draw out a little box for each of the instances you want to spin up, and then it does a little timer from the time that the request was initiated to when all of the instances are available. And what happens kind of behind the scenes with that is first, it's creating a persistent disk. So Compute Engine doesn't have the concept of an ephemeral or a scratch disk. We've moved completely away from that, and everything is a persistent disk now. So it will provision those persistent disks, load up the operating system image on that, and then bring up the virtual machine on top of that image. So this will probably take a couple minutes. It actually takes us a little longer to delete these things than it does to create them. Okay, so how long would it take to do 50? Well, so kind of a little fun thing that I like to do on this is whenever Larry Page gives us sort of an internal talk, he's always telling us to think 10x, right? So rather than just 50, so let's try 500, and we'll go ahead and we'll fire that off, and we'll see how long that takes. So as these things go through, if I were to flip back over to this, as these things kind of go through, they'll change from a gray box, I think, over to a blue box, and then a yellow box, and then finally a green box when the image is actually up and running. So a lot of what I described there just now is the things that are happening behind the scenes as the boxes transition colors. So while that's going, I want to flip over to the, this is the developer's console. And you can see over here on your left-hand side that I'm under Compute Engine and Virtual Machines. And if I look at the disks, we should be able to see, so all of the instances called Quick Start are disks that were created based on that request that I just sent. And then it just has an incrementing integer on it all the way up to 500. And each of those disks, once it's got a green check mark, has been provisioned as a 10 gig persistent disk with the operating system image on it. And if I go back over to Virtual Machines, you'll see, I guess it's creating all of the disks. This is kind of a little precursor to some of the other demos that I have, where I've already got a Chef server and a workstation and an instance that I created from Knife, and that's another demo. And so now you can see some of these instances are coming in, and what they're doing is they're attaching themselves to the persistent disk and actually getting the operating system up and running. And I think we can flip back over to the demo, and sure enough, you can see how some of the colors are starting to flip around. But while that cooks in the background, let's go ahead and go back. And we'll come back to that, and we'll see how long it took us to do 500 instances. So while we're doing that, I'll talk a little bit more about persistent disk. So 10 terabytes, that's a lot of data. That's the maximum amount of storage you can attach to the instance. And you can do that in sort of any combination that you want. You could have a single disk that's 10 terabytes, or you could have multiple disks totaling 10 terabytes, all of those attached to your instances. Depending on the instance size, and I'll show you those in a minute, you can have extra disks or a lot of disks attached to them. You're billed only on the capacity, right? So if it's, it's a 10 terabyte disk and you've got a gigabyte of data, that's all you're going to pay for is the gigabyte. The performance caps scale linearly with the size. So you may have more of an IOPS intensive application, and so you can just create a larger disk and get more throughput that way. Again, it's only on capacity, so if you really just want that size there for the IOPS, you can do that. Differential snapshots, so we support snapshots, and I'll talk a little bit more about that in a second. And you can create new persistent disks off of the snapshots. So use cases for these, root device, right? So your operating system image is going to be on there, and that would be in a read-write mode, obviously. The other thing you can do is have a separate persistent disk attached beyond just that root disk, and again, in read-write mode. So a good combination, like if you were going to say maybe spin up a machine dedicated for Docker use. Your OS disk might only be 10 gigs, but that's not really going to store a lot of images for your Docker containers, right? So you might want to create a separate data disk and attach that and go ahead and mount that up so that your Docker images go off of that larger data disk. The other thing we allow you to do is take a persistent disk mounted in read-only across multiple instances. So it's a great way to replicate data. A caveat here is that if it's mounted in read-only someplace, it can't be also in read-write someplace else. It's just kind of hard to synchronize block level access like that. Oops, sorry. The snapshots. So when you have a persistent disk, you can take a snapshot of that, and that snapshot is actually stored in Google Cloud Storage, and that's replicated geographically. So if you had an instance, in this case in US Central 1A, which is our US zone or region, you could take your instances there and snapshot the persistent disks. That gets saved off into Google Cloud Storage. You could then go over into the Europe zone or the region and create additional persistent disks based off of those snapshots, and then bring up instances using those persistent disks. And then that way you've basically kind of mirrored your setup and didn't really have to worry about doing any sort of data migration or replication. All right, so let's go back and see if that demo finished. All right, 2 minutes and 39 seconds. So that's pretty fast. I think it does take a little bit longer for SSH to kind of get up and running, right? So this is when the box turns green, the operation that you have requested to create an image has completed successfully. The operating system is booted, but then a lot of the startup scripts and things like that are still kind of bringing up to speed. So You might see a couple seconds lag for SSH to get up and running. And I've even seen a few cases where I've tried to SSH in and using a key and it hasn't quite gotten its keys all set up yet. So you can kind of get some weird messages. But if you kind of just loop through whenever SSH is available is a good way to detect when you can actually get in and start manipulating these things. So again, if I flip back over here, we don't have a count, but we should, we'd be able to scroll all the way down and see 500 of these things. So let's go back over here. All right, our machine types. So based on your needs, we've got them kind of categorized into 3 different mixes of CPU and RAM. So our standard size, you've got in the top part of the chart there, we go all the way up to 16 cores, and if you're in the high mem section, you can get up to 104. I think that's 104 gigs of RAM. So depending on what your workloads are, it might be more CPU intensive or RAM intensive. Or if you want to just do some prototyping, we also have shared core instances. So the performance is a little bit less. It's actually, you're sharing it with someone else. A little oversubscribed maybe, so you might see some lag for it to start kind of waking up. But the other ones, we don't do any sort of oversubscription. So if we say, here's 16 cores, those are all yours. Images, we have Debian and CentOS were the first 2 that we had. And over this last cloud event, we announced Red Hat support, SUSE. You can build your own custom kernels now. So it's possible to get other things up and running. So, if your heart is set on FreeBSD, you can do that. Ubuntu, it's all possible now. We even have Windows coming. Debian backports, we also have a backports image of Debian that has like an up-to-date kernel and file system driver. So it's a good one for getting Docker up and running if you're interested in that. All right, so how much does this cost? So I don't have numbers printed on here, but there's a couple things to keep in mind when you look at Compute Engine that kind of sets us apart right now from the competition. One is sub-hour billing, right? So if you had a job where you're only going to run it for 15 minutes, you're only going to pay for 15 minutes. We do have a 10-minute commitment there, minimum, but anything over that starts going per minute. The other thing that we announced at the cloud event a couple weeks ago was the sustained use discount. So you might be familiar with the concept of having to try and reserve instances and figure out what your usage is and sign up and say, okay, well I commit to using it for this next 3 years, and that gets you kind of a discount price. But there's a lot of manipulations you have to go through. And basically, if you're going to use that kind of stuff, you have to kind of figure out ahead of time what is your need going to be and how much capacity do you have, and then you can go ahead and sign up for that. And it's a lot of kind of mental machinations you have to go through to get the best price. And if you don't do it right, you're either overpaying or you're overpaying. You're either overpaying because you overcommitted on what you were going to use, or you're overpaying because you're paying the top rate because you kind of messed up your commitment. So what we came out with was a sustained use discount. And all this means is you don't need to think about that. If you have an instance that you're going to run and you're going to keep it running all the time, once in a billing cycle, once it hits 25% of that billing period, the price starts to get cheaper, right? And if you leave it running 100%, like the entire billing cycle, it'd be 30% less than what you would normally pay if you were just going to turn it on, use it for a little bit, and then shut it back down again. So you don't have to sign. There's no contracts or sign-ups or commitments or anything like that. The longer you use it, the cheaper it gets. Enhanced reliability. So last year, one of the things that we had, we would, if everybody knows this, right? Data centers need to be upgraded from time to time. And when we first launched, we got a lot of feedback because we would sort of force customers to kind of have to work around our refresh cycles. And we've done away with that now. So what we've provided are sort of 2 mechanisms to try and keep your instances up and running all the time. One of them is live migration. And so the way this works is in our data center, we have it kind of split up into different fault-tolerant zones. And within that, we can stagger when we're doing these refresh cycles. And so if we know that we're going to take down these, a couple racks of physical machines and your instance is on there, we can actually move that thing over live with no disruption of your service. So you don't even notice, and we've just kind of moved that around automatically. And we did a demo of this too at the cloud event where we were streaming a high-def video, and while that was actually streaming, we did a live migration and there wasn't even a frame drop on it. So you might see a degraded performance, but generally nobody notices when we do this. The other one is automatic restart, right? If there is an event in the data center where the actual physical machine goes down, it's just a way to tell us that you want your machine to come right back up again, or your VM to come right back up again. On the networking side of things, it's Google's network, right? So I was talking a little bit about that at the beginning. In Google, you have the concept of a project, and a project has the instances in it, and every project has a private network. We support static and ephemeral IPs. Inside your project, you have your own DNS service. So one instance can know the name, the short name of another instance, and that just resolves. So even if the ephemeral IP were to somehow change, you take down your instance and you bring it back up a couple weeks later, it maybe gets a different ephemeral IP, but it comes back up with the same name. Your other long-running instance will still be able to resolve to it. You don't have to manage any sort of internal hosts or DNS. Routes, gateways, VPNs, IP forwarding, lots of good stuff. Load balancer, region-based, right? And so we have 3 resources, if you think of it this way, that describe a load balancer. One of them is target pool, that we call, and that's a collection of the instances that you want to distribute your traffic across. And the other one is a forwarding rule. And the forwarding rule says, for this protocol and these ports, I want to forward that traffic over to this target pool, which is your collection of instances. And then we also support an optional HTTP health check. So you can go ahead and wire that into the forwarding rule as well, so that it periodically pings all of the instances over HTTP, and as long as it gets back to 200 OK, it considers the node healthy and will continue to send traffic to it. We support different hashing options on this, so you can actually get a little bit of stickiness to this if it's important to you. By default, I think we just do sort of a random distribution, so it would be hashed based off of source and IP, and source IP and port, as well as the protocol. Oh, and then I've got a link down there to the bottom if you're interested in seeing this. We did a test last year where we fired up the load balancer, and we went all the way up to 1 million requests per second with no pre-warming. We started from a no instance, empty project. We spun up the machines, and then we spun up the load generators as well, and we created a load balancer, and we just shoved a bunch of traffic at it, and we got it all the way up to 1 million requests per second, all to a single IP on the forwarding rule. A couple other things to quickly mention. Regions, we're in Central United States, Europe, and Asia is brand new. We just announced that. We have our own internal metadata service, and I'll show you a little bit about that with the demos. SSH keys to access your instances. Tagging of instances and networks, so you can create firewall rules based on tags and rather than IP ranges and having to manage all of that. OAuth 2 and scope so that you can access other things. And a growing ecosystem. Not only do we do Chef, but we're also in Puppet, Salt, Ansible, Vagrant, Docker, Koros, Fog, and libcloud. Lots of other commercial partners as well. All right, so using Chef and Compute Engine. So my environment, I showed you the little screen, the developer console where I had a couple of these instances. I've got a Chef server that I used CentOS in and just followed Chef's, this is the open source version of the Chef server. And then I created a Chef workstation. I used the Debian 7 image and then the Omnibus installer. And then I used Knife Google. So we have a plugin that we've contributed to the open source community. It was originally written by Ranjib Day and Paul Rossman here. It's, it's Knife, right? So everybody knows Knife to bootstrap an instance. So this just allows you to do it over with Google's API. So quick little sample. I'm not going to do a demo on that because I want to show you the new stuff. But you would run Knife Google setup, assuming you install the gem, right? Knife Google setup, and you have to have created the credentials, and you kind of feed that into this tool. And then after that, you could run knife Google server create. You can pass in a run list, give it the credentials, the image, size, location of where you want it, and it runs off and provisions that and then bootstraps it. It does other goodies like persistent disks, zones and regions, but not much else, right? Like I talked to you about firewall rules and load balancer, but knife Google doesn't really support all of that. So what we wanted to do was give you access to all of the GCE features. So we're introducing the GCE Lightweight Resource Provider. I finally remembered. Thank you, Adam. He had to tell me like 100 times. I could never remember what the P stood for. As far as the demo goes, my done part of it is I've already created the environment. And what I want to demo is I'm going to show you a command. And let me go ahead and just flip over to that. Oh, so here's the example of my knife Google server create, right? So you see the actual tail end part of it there where it bootstrapped it. So I'm going to use, this is on my Chef workstation, which is again inside of GCE. So I'm going to use a Chef client local mode or Chef 0. I think that's not the preferred term. And then I'm going to pass in the run list, or the recipe rather, with the -o flag. And I'm going to give it this recipe, and I'll walk you through the recipe. So assuming this gets started. All right, so you can see it down here at the bottom. It's doing a GCE instance of my instance 1. And there's it's using boot disk my instance 1, and it created it. So while that's going, let me go back over here to this. So what I'm going to do with the demo is we're going to create 4 instances, 2 in US Central 1A and 2 other instances in US Central 1B. And then I'm going to create a firewall rule that lets port 80 traffic into your instances. And then I'm going to create a load balancer for those 4 instances. And then we'll test it all out. And this is all running from my Chef workstation, communicating to the GCE public API. And then we're going to generate some HTTP requests. And there's a little icing on the cake on this. So here's the full, this is the section of the recipe to create the instances. So if I kind of walk through this, I'm just using Ruby to iterate through 4 instances. And I'm specifying it's an N1 standard one. Oh, sorry. If I've got a couple variables that are defined sort of outside of the file, but I didn't want to include those to kind of clutter up. I was running out of space. Hopefully everybody can read that. So the name prefix is called my instance, and then I'm just tacking on a 1, 2, 3, or 4. And then I'm just detecting whether that's an odd or an even number to kind of split them out into 2 different zones. These are the standard attributes, and so I'm kind of also showing off that we added a lot of support for sort of the edge cases, things like setting up service account scopes. So these instances, as they're being created, have full access to Google Cloud Storage, which is the last scope you see there, the dev storage.full control. They also have compute access, so these instances could actually create other instances within Compute Engine. We'll talk more about that in a second. I'm adding a tag and some metadata. I'm setting the auto restart to true and on host maintenance migrate, right? So this will shuffle things around. I'm enabling turbo mode, or what I call turbo mode as a cute name. What this means is it's, I've got wait for set to false. So the way Compute Engine works is most things that change the state of your environment, you send it a request, and it hands you back an operation ID, so a transaction ID. And you can just poll on that, and you can say, are you done yet? Are you done yet? Are you done yet? And when that operation status flips to done, you know that whatever it was you requested has completed successfully. So in my little turbo mode, I'm saying I don't want to poll on that request. I want to just send the request. If I get 200 OK, that's good enough for me. I'm going to move on and do the next thing. Bootstrap attributes. OK, so great. You can create Compute Engine instances and you can write a recipe, but that's kind of pointless if they don't join your Chef environment, right? So what we've done here is we've kind of used a clever way of our metadata service as well as stuffing in some data there, and then a startup script. So when these instances boot up, they are, assuming I've got these attributes set in my recipe, I'm going to take the contents of these files and put them up into our metadata service. Then there's a startup script that will get executed on the instance when it comes up, and it'll look at the metadata service, detect that it needs to execute a startup script, it will pull those values right out of the metadata service and then drop them down on the local disk of the instance. So the things that we're passing it are the data it needs for the client.rb file, the chef's validation PEM, and the initial run list, which we put into Etsy chef first boot.json, I think. So when all of this and this is actually what's happening right now behind the scenes when I fired off that command. And then I'm taking all of the line 24, I'm just collecting all of the names of those into a servers array. So the rest of the recipe, this is all one recipe, even though I reordered the numbering here. So GCE firewall, I'm creating a firewall that lets port 80 traffic in. I'm creating a load balancer. I'm telling it to go check port 80, and the request path is just /. So again, the health check is if it gets a 200 OK back from the web service, it considers the node healthy. We set up a target pool, and there's line 14 where I'm telling it what instances I want to create in the target pool. So that's why I was collecting it in the array before. And I'm also telling it to use that health check. And then I'm setting up the forwarding rule that says, you know, for this port range, for TCP, and using that target pool, let's set up that forwarding rule. So let's flip back over. So in 39 seconds, we created requests for 4 instances, the firewall rule, the load balancer, and the target pool. And meanwhile, what's been happening in the background when those instances come up, as I was describing to you, they're pulling the metadata service. They detect that startup script. So with luck, what we should be able to do, I say with luck. Let's go over to our chef server and see. So that was the node that I created with knife. Yay, all 4. The other thing that we did with this is we dropped down an OHI hint to say that this was a GCE instance. So we should be able to see a bunch of OHI instances, and this is Paul's work here. So we've got things like the machine type, the host name, project that it belongs to, network interfaces, there's its public IP, or I guess its private IP. So all of that is in there. Now let's go over, let's test this out. Oh, what I should say is I also, when I created these 4 instances, I wrote a little custom cookbook for ChefConf that all it does is deploys Apache, sets up mod headers, lays down a custom index.html file, and then uses an OHI hint to put the name inside of the web page, like it sets the web page's title. So we'll see. Where am I? Let me go back and go down here. So again, under Compute Engine, we've got disks, snapshots, images. So I want to go down to load balancing, and let's take a look. This is the forwarding rule. So let's look at our target pool, and it should have 4 instances, and they're all listed as healthy because we also created that HTTP health check. And it's only looking at /, and it's getting the 200 OK. So all of our instances are healthy. And I can come over here and I can grab this public IP of the load balancer. And when I paste this in, it's going to go to the load balancer and hopefully splay across the 4 instances behind it. So we should see this bounce to 1, 2, 3, and 4. There we go. Google primary colors too, no less. So there we did it. So we wrote a nice little recipe that lets you create all of those. I'll go back in here. All right, so available now and what's coming. So Knife Google has been available for, I don't know, a year or so now. And we've kept that updated. So as Google has come out with new features and releases, Paul's been very good about keeping it updated. And then we also have the Google Compute Engine LWRP. And I say it's coming soon. So Adam set up a GitHub repository for us, and I'm going to hopefully populate that this evening with our first pass at this. And you're welcome to, I would love it if you guys like kick the tires on this thing. I handed out cards where you get 500 bucks, right? So maybe go kick the tires with this and tell me what I'm doing wrong, and we'll make it better. You can create and destroy instances, obviously Bootstrap as I showed you. Snapshot disks, you can set instance tags and metadata. You can manage networks and firewall rules and the load balancer and health checks, all that with recipes. The other thing that I wanted to bring to your attention, we have a booth, I think it's upstairs one floor. We have a partner that we worked with, Cloud Technology Partners, and they built another working demo. So please stop by the booth and check it out. This is pretty exciting stuff that they've got. It's a developer's and chef administrator's best friend, right? So it's a self-provisioning portal that uses Compute Engine. And as an administrator of this tool, you can go in and set your predefined templates and cookbooks. And then your developers, in theory, can just go there to this managed portal and say, I want to go develop my application. They push a button. Their tool goes out and talks to Compute Engine, spins up the instances, deploys the cookbooks, and the developers can get in and get their work done. And they haven't even bothered you once, right? So please go take a look at that. And lastly, so try it out for yourself, right? So I was handing out cards, but I didn't get everybody. But please stop by the Google booth and pick up a card. We're handing out $500 in credits for you to go ahead and test Compute Engine and get up and started. You have to use the promo code chef14-con. A couple links there where you can read up more information about Compute Engine and Chef and Compute Engine. And then I've got links to Knife Google, the GCE LWRP, and there's also Test Kitchen GCE, which I haven't personally ever played around with. But big shout out to Andrew Leonard for doing this. So I haven't met Andrew. If anybody knows Andrew or Andrew is here, I would love to meet you. Questions? I'm going to be at the speaker office hours today from 4:15 to 4:35, or you can find me on GitHub, Johnso. And that's all I have. Any questions? You can find me anywhere. I'll be walking around all day. Okay, great. Thank you very much for your time.